So we're moving forward into the new packet that was placed on your desk pertaining to graphs of sine and cosine. So on your graphing calculator, what you first want to begin by doing is hitting the mode key. And you want to enable radian mode instead of degrees. So you're going to hit mode, and then you're going to highlight 4 lines down radian. Okay, so radian instead. Bless you. So radian instead. And we're going to start right at the top here. Okay, so we've been working with sine and cosine past week or so. Now you're going to see what these look like graphically. So when we do trig graphs, we frequently use radians instead of degrees. And again, it's just an alternative way to measure an angle. So when you create a trig graph, what we typically use are increments of pi over 2. And pi over 2, just like we did the version yesterday, pi over 2, 180 over 2 is just simply 90 degrees. So these two, one's in degrees, one's in radians. You just want to be comfortable with going back and forth. So we're going to start with just a basic sine function and cosine function. And you're going to list all of these quadrantal angles and their measurements below. And these are all the ones that you did on your unit circle. So unit circle, pi over 2 was 90 degrees, just so you can kind of relate that to what you did yesterday. Pi was 180 degrees. What do you think 3 pi over 2 would be? 270, yep. And then my next one over here would be 360. Again, I'm just doing that so you can kind of relate it back. And radians are just a different way to measure the angles. And then back the other direction too, I would have 0, I would have negative 90, I would have negative 180, negative 270, and negative 360. Okay. First thing we're going to do is we're going to get all of these values for our cosine. Okay, so pick up your calculator. Let me show you how to do this. And we are going to type in negative 2 pi and all the way across the first row. All right, so in your calculator, you want to type in cos. And we want to go negative 2 pi. So negative 2, and you're going to find the pi key. It is second caret right there. And hit enter. Bless you. So that one's 1. I'm going to do this. I'll type them all and then we'll write them, just so I don't have to keep going back and forth. The next one, I want you to look closely as to how you have to type this. You need a double parenthesis. So you need to do parenthesis, negative 3 pi, and you need to keep that product together like that. And then divide it by 2. Enter. Okay, so that is one way that you can type that. So 0. Again, these are from unit circle, so they should make sense. Next value is going to be cos of negative pi. So negative pi, again, we'll write them down in a second. Negative 1, and then next is cos of negative pi over 2. Let me have you try this. Those of you that have newer calculators. Try alpha y equals enter. And see if you can type negative pi over 2 like this. See if it'll do it. Then you don't need double parentheses. Does that work? There you go. So that's your other alternative. So you can type it like line number 2 that I did, or 4, just depending on what calculator you have. Let's write those down. 1, 0, negative 1, 0. So you are going to type in here. So 1, 0, negative 1, 0. And now keep going. What do you notice about the cosine of 0? It's 1. And then this is just going to repeat a pattern. So what comes after the 1? What did you guys get? 0. And then pi, negative 1. And then 3 pi over 2 was 0. And then 2 pi was 1. Trig functions are what we call periodic, meaning they're going to be symmetric and they're going to follow the same pattern. Now, using your first colored pencil, I want you to come down to this graph and let's plot this. So what was the highest value that this cosine graph hit? 1 and the lowest is -1. Okay, so let's space this out so our graph looks nice. So I'm going to do every other. So this would be 0. And skip 1, this would be 1. Skip 1, that would be 2. We don't have to go that high, but just to have it. And then -1, and then -2 would be on the bottom. And then you're going to plot these values and connect it like a nice smooth curve. So -2 pi 1. I have my next point down at 0. And at -pi, I'm down at -1. And then you're going to go right back on up. Again, these are symmetric. So there's half of it. I find sometimes it's easier to draw a nicer picture and do like half of this at a time. So I'm going to start and do this. And then we'll do the other side. So here's your first side of your cosine curve. Now I'm going to do the other side. Again, it's symmetric. You can just use the same pattern if you'd like, if that's easiest. And right back up. All right, so we're going to just swoop it down. And you want these to be nice rounded curves. You don't want to be using a ruler for any of this. Okay, so this is the graph of y is equal to the cos of x. Now we're going to do something very similar to graph a sine curve. So I'm going to switch colors and go back up to my table, just so you know everything coincides here. So I want to do sine of x now. I'm going to type all those in the calculator until we establish a pattern. So I need to type in sine of -2 pi. And again, these are all unit circles, so your values are either going to be 1, 0, or -1. What is the sine of -2 pi? You guys have it yet? 0. Thank you. Appreciate that. Is the next one -1? And then 0? And then next, sine of -pi over 2 is -1. Oh, I'm sorry. Was this one supposed to be at 1? Sorry. There we go. All right, next value. I have the sine of 0. Excuse me, that's at 0. And then 1. Excuse me. 0. -1 and 0. Go ahead and plot those. We get these at 1. So your graph should look like this. We have 0, 1, 0, -1, 0. And again, I like to do the graphs half at a time, just for your studying purposes. So here is a sine curve. And then right back around to the other side. And 0. Down at -1. And back up to 0. And this is the curve y equals sine of x. What do you guys think so far? Pretty manageable? Okay. Again, those are your two basics. We haven't done anything as far as stretching those out or changing the amplitude just yet. So it says letter C. The domain and the range of the sine and cosine functions are the same. Domain pertains to your x values. Range pertains to your y values. So state them both in interval notation. So my domain, what would happen with these graphs is they would go on forever. So I could graph them forever to the left, forever to the right. So we say when we can graph something forever, that our domain goes from -infinity to infinity. If you think back as well, that was also associated with all real numbers. You may have seen it in that capacity. Then the range is just the y value. So I look at my graph and I find the lowest y value that I'm at, which is right here. Highest y value that I'm at is up here. So where's my graph located? In between those. So my range goes from -1 to 1. And when I use interval notation, and I include those values, you associate that with a square bracket. Okay, so just like that. Next question asks you, after how much horizontal distance will sine and cosine repeat its basic pattern? This is what we refer to as the period of a trig function. So that's a vocabulary term. Again, your trig functions are all what we call periodic in nature because they repeat those patterns. Did you guys notice that the left and the right side are the same? Okay. So after how much horizontal distance? 360 degrees, which is equivalent to 2 pi. And that is what we refer to as the period of those trig functions. And that is the time it takes to complete one full cycle. So it is the time it takes to complete one full cycle and repeat again. Okay, so that's your first vocabulary term. Anyone need a second to sketch those graphs? You're good? Nope, I'm sorry. Bottom says period time it takes to complete one full cycle. I'm sorry, I know that got kind of low. So now all we're going to do is experiment with stretching these out. You're going to draw a couple at once here. So we're going to look at changing the coefficient that's located in front of your function. The coefficient is denoted by the letter A. And what A stands for is what we call the amplitude of the trig graph. And the amplitude means the height. This pertains to the height. And we always do the absolute value of that number because it is never negative. You can't have a negative height. So it's never going to be a negative number. So on this graph below, you have a cosine curve, just like what we did on the front. Calculator gradient mode, we already did that, so we're good. Now what we're going to do is add on these other graphs here. I'm going to show you how to do this in the calculator. So this is just a cosine curve, like we did on the back. This has an amplitude of 1, so that was a 1, a 2, a 3, and a 4. So this graph just goes by ones instead. -1, -2, -3, -4. Okay. And what we're going to do is we're going to use 3 cos of x. So this has, I'm going to use my first colored pencil, what we call an amplitude of 3. That means it's going to go up to 3 and down to -3. Okay. Here's how you put this in the calculator. This takes some practice, okay? I am going to go right to the window of the calculator. Window. And I'm going to read these directly off my paper. The x minimum, if you look at your graph, is the value that is labeled all the way to the left. And that is -2 pi. So you type -2 pi. And as soon as you hit enter, it's going to change it to a decimal. That's okay. The x max, you're going to look right at your axis. Look at the x, and what's the biggest value all the way on the right? What does that say? 2 pi, exactly. So 2 pi. Enter. The scale is 90 degrees, which is equivalent to pi over 2. All right, the y minimum. What is the smallest y value that was labeled on the axis? Wasn't it -4? So -4. The maximum was +4, and we scaled it by 1. So you don't have to change anything else in your window. This window right here is a very standard window that we use for a lot of trig graphs. So you'll see this one a lot. So now you go to y equals, and you're going to type in 3 cos x. I'm sorry, why did I say sine? Wasn't it cos? Thank you. 3 cos x. Enter. So now you're going to hit graph. And what you should find when you hit graph is it's going to be set up exactly like your paper. You guys see it? So it will draw it for you. Then all we're going to do is pull these values off. So it splits your screen. So over here, this is 0. This is pi over 2. This is pi. This is pi over 2. This is pi. Same thing on the other side. So this first value is up at 1, 2, 3. So we're going to go 3, 0, negative 3, 0, 3. And then it's up to you. You can do the rest in your calculator, or if you see the little pattern, you can just do it the fast way. So, same color in my hand as this one. I'm going to color coordinate these. So I'm going to go up to 3 and 0 and negative 3, 0 and 3. All right, we're going to draw a nice curve. And other side as well. And negative 3, 0, and 3. And again, extend this side as well. You'll notice we stretched this out. So this cosine curve has what we call an amplitude equal to 3. All right, the next one. Let's do these out of order. I'm going to jump down to the third one. That one says 3 divided by 2 cos of x. What do you think that's going to hit as its highest value? Any ideas? What's this amplitude? Number in the front, 3 over 2. 3 over 2. So you can certainly type that in the calculator again if you'd like. That's why I showed you that. Or I can just do this the fast way as well. If this points at 1, it's going up to 1.5 instead. That point won't change. This one's going to go down to negative 1.5. This one's 0. And then next is 1.5. So you've stretched it out just a little bit here. Back the other side, 0. And negative 1.5, 0, and 1.5. So you're more than welcome to use your calculator, or you can just take the function that was there and just multiply it by 1.5. Okay. Now the second equation. There is a negative in front of it. And you just wrote down the amplitude cannot be negative. And it can't be. That negative is a concept you discussed in geometry. When you have a negative in front of a function, this means that it got reflected over the x-axis. And it has an amplitude of positive 4. So the negative is the reflection, the 4 is the amplitude. You can certainly type this in as well if you'd like to, or again, you can do this by hand. I'll show you what it looks like on the calculator first in case you'd like to use that. Because we don't ever take the calculator away, so you can use it for any of these that you'd like. All right, so I'm going to go y equals, and I'm simply going to change this to negative 4 cos x. And you're going to see that it flipped. You guys get that okay? Yep, so that's what you're going to sketch. The lowest value is negative 4, highest value is positive 4, and everything else is just a value of 0. So I'm going to sketch this one. stay on that -4, 0, +4, 0, -4. And this one I'm going to do in blue. I'm underlining so I don't have to label, because this gets kind of messy when you have so much going on. Continue your graph symmetrically on the other side. All right, and you're good to go. Okay, so that has, again, what we say, the answer to the 4 reflected over the x-axis. So your last graph that you're going to place on the same coordinate axis is -2 cos of x. So -2 cos of x is also another reflected graph. But what is my amplitude instead for this one? Just 2. Yep. So this one is going to go up to 2, down to -2. So that's the negative sign right there. So again, if you find it faster to just take the existing graph and work with it, or a calculator. So instead of going down to -4, I'm just going to go to -2, 0, 2, 0, -2. Let's get that one going. And other way. And I do understand it's tough to look at so many things graphed on the same axis. Homework, feel free to do those in colored pencils too. Again, I think it helps a bit. And then down to -2. Okay. So there are 2 cosine curves, plus the original that was already there. Amplitude we've discussed. So that is your height of your graph. And then all we're going to do is a couple sine graphs as well. Let's see if we can do these the fast way. So with your sine curve, here's your original again. So this is just going up to 1 and up by 1s. Excuse me. So 1, 2, 3, 4. Back the other side would be -1, -2, -3, -4. And I'm going to go back to my first colored pencil. 2 sine of x. So 2 sine of x is going to have an amplitude of what? Just 2. So this point stays the same. And this point goes up to 2 instead. 0, -2, 0, 2, 0, -2, 0. And you're going to connect it with a nice smooth curve. Like that. All right, my next one is going to go up to 4, down to -4. So this has an amplitude equal to 4. So 0, up to 4, 0, -4, 0, 4, 0, -4, 0. So this one has more height to it. Going up to 4, down to -4. All right. My next sine graph is a reflected graph. Down to 3, up to 3. You are welcome again to use the calculator. Amplitude is 3, always positive. And this, once again, because of that negative, is reflected over the x-axis. Okay, so I'm going to just use this. So I'm here. So I'm going to, instead of going up, I'm going to go down. So -3. Oh, I'm sorry, 0. Sorry, they'll start the same. -3 is next. 0. positive 3, and 0. All right, so it looks like this. Down to negative 3, up to 0, up to 3, and then 0. All right, so you're sketching it just like that. That was my yellow. And last, I have one more reflected graph, but this one only has a height equal to 1/2. So amplitude of, I'm going to state amplitude. My height is 1/2. And again, that negative pertains to my reflection over the x-axis. So reflected over the x-axis. I'm going to just shrink this up. So 0, and then negative 1/2, 0, positive 1/2, 0. I'm going to start this one. Negative 1/2, 0, 1/2, and 0. Right. What do you guys think? Are those manageable? How do your graphs come out? Yeah, it does take a little bit of practice to do those. Again, no rulers, just make sure they are nice smooth curves. Okay, so your homework is on the other page. You are welcome to take your last 10 minutes and make use of the calculators if you want to, or you can just very quickly draw these by hand too. So you're going to start with just a basic sine function, then you're going to stretch it up to 3, then you're going to just reflect it, so on and so forth. Okay, you're welcome to continue using colored pencils, calculators, whatever you need. But there is a backside as well. Yes. What's up? Yes. Yep, your first example on homework just goes up to 1, down to -1. And I would recommend scaling this by just once, because you're going to have to fit. Do you see this one has a 5 in it? Yeah, so go by once.